Theivanai Ammal College for Women. Learn, live and lead.
Hello friends, I am Miss M. Anandhi, Assistant Professor, PG and Research Department of Mathematics, Theivanai Ammal College for Women. Today I am going to discuss the topic measurable set in measure theory. The set E is measurable, A is contained in R. We have to say outer measure of A is equal to outer measure of A intersection E plus outer measure of A intersection E complement. This condition is satisfied. We have to say the set E is measurable. Based on that definition, we have to see some theorems show that E is measurable if and only if outer measure of A is greater than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. First, you have to write E is measurable. E is measurable means we have seen, we have to see outer measure of A is equal to outer measure of A intersection E plus outer measure of A intersection E complement. So obviously we know that outer measure of A is less than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. And also outer measure of A is greater than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. So both the inequalities are there. So they said, so we have to prove that case only. So outer measure of A is greater than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. Conversely, we have to prove. That so we have to take outer measure of A is greater than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. So we have to prove E is measurable. So outer measure of A is less than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. In that case only we have to prove. It's enough to prove. Okay. So we have to consider A equal to A intersection B union A intersection B complement. Consider the Venn diagram. So you have to take A, B. So first you have to take A intersection B means, so this portion you have to shade. Then other A intersection B complement means you have to shade B complement. Then intersection A means we have this Venn diagram. So take the first diagram and second diagram, you just union, you take union. So we get only A. So only we have to write A equal to A intersection B union A intersection B complement. Then taking outer measure, so M star of A is equal to outer measure of A intersection B union outer measure of A intersection B complement. So and already you know that the basic concept by countable subadditive. Countable subadditive means you have the union means we have to change summation. That's you have to say countable subadditivity. So outer measure of A intersection B union outer measure of A intersection B complement is less than or equal to outer measure of A intersection B plus outer measure of A intersection B complement. So we you have to substitute this into this. Okay, we get M star outer measure of A is less than or equal to outer measure of A intersection B plus outer measure of A intersection B complement. So we this is the condition for measurable. Already we seen. Okay, this is measurable. This complement is measurable. This is complement. So we have to see this is the we have to prove M star of A is less than or equal to M star of A intersection E plus M star of A intersection E complement. So we have to say E is measurable. So next we have go to the some more theorems. Next, if E is measurable, then E complement is measurable. Okay, first we know that E is measurable means what you write? E is measurable means outer measure of A is equal to outer measure of A intersection E plus outer measure of A intersection E complement. That's it. Okay. Then you have to replace A intersection E complement whole complement. That is also E. Okay, you get only E. Then plus outer measure of A complement A intersection E complement. Okay, first interchanging this term. So you get A intersection E complement plus outer measure of A intersection E complement whole complement. In normal, E is measurable means the E is measurable, then E complement is in second term. Okay, so this term is measurable, then second term this complement is there. Okay, so this is same. Okay, you have to write. So you have to write M star of A is equal to M star of A intersection E complement plus outer measure of A intersection E complement whole complement. For that you have to say E complement is measurable. This is you have to prove. E is measurable, E complement is also measurable. Okay. Next you have to see some more theorems. The next important theorem is every interval is measurable. So you take any interval, you have to prove the measurable. Already we know that E is measurable means if and only if outer measure of A is greater than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. So I can take interval half open A comma infinity. So we have to prove outer measure of A is greater than or equal to outer measure of A intersection half open A comma infinity plus outer measure of A intersection minus infinity comma A. That means you take this interval. So by the definition of measurable, you take measurable means the second term is a complement. That's it. So closed interval A comma infinity means A comma infinity, this E. So E complement means other than that set. Okay, then A comma minus infinity. This is a full open set. Okay, so this condition is proved means the theorem is proved. Okay, so you have to take A1 equal to A intersection minus infinity comma A. Then this is represented by A2 A intersection half open A comma infinity. So by the definition of outer measure, for any epsilon greater than 0, there exists an interval In such that A is contained in union n equal to 1 to infinity In. So we have to define outer measure of A is greater than or equal to sum of n equal to 1 to infinity length of In minus epsilon. So this equation represents as 1, this equation represents as 2. So next we have to consider In dash. That means the subintervals. The interval is actually In, but you have to take In dash and In double dash. So In dash take from A1 and In double dash take from A2. So In dash equal to In intersection minus infinity comma A. Then In double dash equal to In intersection half open A comma infinity. So this is contained in the set A1. So A is contained in union n equal to 1 to infinity In dash. Then similarly A2 contained in n equal to 1 to infinity In double dash. So already we know that countable subadditivity means the union is termed as a summation. So this term converted as M star of A1 plus M star of A2. That means M star is outer measure. Okay. The outer measure of A1 plus outer measure of A2. This is we can use a countable subadditivity. This union is converted into less than or equal to sum of n equal to 1 to infinity length of In dash. So A1 is contained in In dash. Similarly A2 contained in In double dash. So this value is so same that interval, this interval is taken from in. So we have to write that is equal to sum of n equal to 1 to infinity L of in. Okay, then from equation 2 you have to say this from equation 2 sum of L of in, this minus infinity comes from right hand side, outer measure of a plus epsilon. So you have to substitute sum of n equal to 1 to infinity length of in. So you have to substitute outer measure of a plus epsilon. So we have to conclude m star of a1 plus m star of a2 is less than or equal to m star of a plus epsilon. Epsilon is arbitrary, you take means outer measure of a is greater than or equal to outer measure of a1 plus outer measure of a2. But in previously we can consider a1 as a intersection minus infinity comma a. Similarly a2 means a intersection half open a comma infinity. So I can take the interval half open a comma infinity. I conclude that outer measure of a is greater than or equal to outer measure of a1 outer measure of a2, that is a intersection a comma infinity. So you have to say this condition is satisfied, mean already we know that E is measurable means if and only if outer measure of A is greater than or equal to outer measure of A intersection E plus outer measure of A intersection E complement. So likewise we have to say that interval, that particular interval is measurable. So similarly we can take any other interval, you have to prove that the interval is measurable. Today we conclude this section. Thank you.